A quick review on K-space filling. High amplitude gradients are going to produce more edge detail and are going to be placed in the outer edges of K-space. Those would be your steep gradients or high amplitude gradients. Shallow gradients or low amplitude gradients are going to be more responsible for our image signal and contrast, and those signals are going to be placed in the middle of K-space, and they contain the highest signal to noise. When we're doing our angiography exams, one of the things we do have to consider is our K-space filling options. So let's take a look at those. In phase encoding with sequential filling, if we had 128 lines of K-space, we're going to basically scan line 128, 127, all the way to the center, and then we would scan the positive steps. So we're going to start with negative and scan to positive. The middle of the acquisition determines the contrast of that image. In addition to not only when we're going to deliver our contrast and where we're going to scan, how long our scan is going to be, what kind of breathing instructions we're going to give, you also have to take into account what type of K-space filling you're using. We have a couple of selections we can choose from. Sequential K-space filling is one. Basically, this is going to fill the central lines, and then those lines are going to be filled in the middle of the acquisition time. So we end up with a basic formula of time scan delay equals time of circulation plus half the time of the gadolinium injection minus time of half the acquisition. And we can actually calculate this out mathematically. This is an example that came from your textbook. Basically, our subject has a circulation time of 18 seconds. We have a 20-second acquisition time. We're injecting 20 milliliters of GAD at a rate of 2 milliliters a second. So if we fill in all those magic numbers, we can actually calculate that we need a scan delay for our patient of about 13 seconds if we're using this sequential K-space filling. This is going to help us avoid that ringing artifact that I said timing was important. So this will help to minimize that particular artifact. Another method of K-space filling, again we're talking about our phase encoding, is centric. Centric is also our conventional or linear method that we've learned from the very beginning. We basically are going to scan a line in positive for a line in negative until we reach our 128 in this particular example. So it would be +1, -1, +2, -2, all the way to +128 -128. The beginning of the acquisition is going to determine the contrast resolution of that particular exam. With centric filling of K-space, we have a slightly different formula for our time of delay. With central lines, again, we're going to be filling the central lines of K-space the first half of the scan. So because of the way the data is acquired, our formula is just slightly different. This time we've got the time of scan delay equals the time of circulation plus half the time of gadolinium injection minus the time for the center of K-space. Now, it just so happens with this example that came from a book that I have, that the subject circulation was 18 seconds. The acquisition time was 20 seconds. We gave 20 milliliters of gadolinium at an injection rate of 2 milliliters per second. So that gives us, with half of that being 5 seconds for the injection for the first half. So when we end up with our formula, we have the time of scan delay equals 18 seconds plus the 5 second, which is half the scan delay, minus the 5 seconds, which it takes us to get to the center of our K-space. So we end up with a time for our scan delay of 18 seconds for this particular MRA exam. Elliptical K-space filling is another type of phase encoding filling that we can use in K-space, in which we have an elliptical The last type of case-based filling is actually one of the more common techniques used for contrast-enhanced MRA, and that's keyhole filling. Case face is going to be filled completely only in the first image set, which will be pre-contrast. All the following or subsequent images in this particular exam will only fill the central portion of case space, or approximately 20% of all the case space. The remaining 80% of the lines, which would be the outer portions, are just going to be filled with the same data that was scanned during the first pre-contrast data acquisition. So that data will just repeat in each of the acquisitions, and only in the center of case space where our vessel is located will we fill that data repeatedly as the contrast flows into and out of that area. This significantly reduces our scan time and allows us to be able to scan ultra fast for our contrast enhanced MRA exams.